Hello, my name is Kiro. I work in Teletech Electronics Product Management Department as technical support. This video, it's going to cover the Iris programming and the options that the panel has. For the purposes of this video, I'm going to open up ProsTE programming software and I'm going to share my screen with you. This is the Iris panel template that I loaded up into the screen. The first topic is silence delay. By default, the silence delay is off, which means in the moment of occurring fire or evacuation event, the silence will go on right away. A lot of times you need a delay of the silence in order to investigate the zone of fire and have time to go back to the panel and reset the panel before the sounders goes on. By default is off. If you want to use any of those delays, you have to switch it on, or you have to make a schedule for it. When to be active, when deactivate. For our purposes, we're going to use sounder delay mode on. There is 3 delays when we talk about sounders action: T1, T2, and T3. T1 and T3 are general delays, and T1 belongs to the zones. If I open up a zone here, you'll see that every zone has its own delay that you can set up. We'll go back to the zones later explaining their options. For now, we just have to know that every zone can be set up with a different delay for the sounders. The reason for that is because every zone is physically in different location and different distance from the guardhouse or security guard personnel, if there is any, and it would respectively need different time to go there, investigate, and come back to the panel. So, going back to main page, first you have to enable the delays. Then we're going to go to T1 delay, which is here. By default is 0. T1 delay is designed for reaction on the panel. If it's set to 0, that means it's disabled. In case of fire, there is no need of action from a security personnel on the panel screen in order to start the delays that you set up by the zones. If you put that number, it's in minutes. If you put it in any different number than 0, the settable time is up to 60 seconds. Sorry, not minutes. The settable time is up to 60 seconds. How is that going to affect the panel? Let's say I put 30 seconds in. In case of fire event from a zone, the panel will acknowledge the fire. The panel will show the fire event, and it will wait 30 seconds for security personnel to press silence buzzer, because it's going to activate his internal buzzer to notify for the event. If nobody presses silence buzzer within this specified time, 30 seconds, the panel will consider that there is nobody there on the site, no live attendants, no security personnel that acknowledge the event, and there is no point of activating the delays that you set up for zone. So the panel, if that time expires without any action, not any action, silence buzzer on the panel will start the silence right away as soon as this delay expires. If within this delay, T1, if somebody presses silence buzzer, the panel considers that there is that the fire event is acknowledged, and somebody's going to go and check in the fire in a zone with fire if it's a real one or if it's a false alarm. So we'll jump directly to T2 delay that you set up for the zones. Again, if you set it up to 0, you disable this T1 delay, which means fire comes, you set up a 5 minutes delay for zone number 1, for example. Fire comes from zone number 1, the panel will start automatically the delay for that zone. It will not expect somebody to press silence buzzer on the panel screen. The T3 delay So T1 delay is for reaction on the screen. The T2 delay belongs to each zone separately. The T3 delay, the last delay, it's called evacuation timeout. I'll put it different words. Time before general evacuation. This is so-called phase evacuation. Again, I'm going to give you an example in order to better understand or better explain what time before general evacuation means. Imagine you have 5-floor buildings and each floor is a separate zone. It's zone number 3, respectively, floor number 3. There's fire. Now we want to evacuate the people from zone number 3 before the other floors, because this is the problematic zone. This is the problematic floor. You want to evacuate the people first. Because if you evacuate all the floors at the same time, you might get staircase congestion, and the people from the problematic floor might not be able to go out and evacuate the zone. So if you set up this time, T3, to it's set up to 10 minutes. If you set it up to 1 minute, what the panel reaction is going to be? You get a fire from floor number 1, floor number 3. The sirens in floor number 3 turn on. And after 1 minute, all the sirens in the whole building will turn on and announce the fire and evacuate the entire building. Now, this is applicable, of course, when you set up the sounder mode to zonal. If they're set up to common, then all the sirens will turn on simultaneously. So this is the 3 time delays that are applicable for the sirens. And it's very important to understand that this is not delaying of the event. If the event occurs, the event of fire, if the event fire occurs, it's registered into the panel, and the panel will announce it by displaying it on the screen and with the internal buzzer turning on. You delaying just the action of the sirens. Next, we're going to look into day-night schedule. Day-night schedule is referring only to the performance of the smoke detectors and combined detectors. Their sensitivity can be set. I'm going to show you quickly here. I put up some detectors. You have the option to set up sensitivity for day mode and night mode, and they can be chosen. And the options are 4 options that you can choose from for day mode and night mode. I'm going back to the main page where we left it. This day-night schedule it's affecting the work of the detectors, as I mentioned just a second ago. By default, the day mode is off, which means the panel will disregard the setting for day mode of the detectors. If you have the option to turn it on, that would mean that the panel will act as a day mode constantly. If it's off, it will be night mode constantly. And if it's a schedule, you can tell the panel when to activate the day mode and when to deactivate the day mode. And respectively, the work of the detector, smoke detector, and combined detector is going to change according to this schedule. Sounder mode. Sounder mode goes together with call point mode, sort of say. Remember the example that I gave you with the 5-floor building. If you set up sounders to zonal and call point to zonal, that means that if in case of fire, only the sounders that belongs to the zone with fire will turn on. What the call point will do, respectively, it will trigger evacuation in the same zone that they belong to. In other words, it won't trigger all the sounders in all the building. If you set up the call point to common, this will activate all the sounders regardless of the fact that the sounders are set to zone. So that's why I'm saying they kind of go hand by hand. So now it's important to know that in fire alarm panels, there's 2 different separate events. One of them is evacuation. It's triggered by call point, manual call point. And the other event is fire. So it's triggered by automatic detectors. So fire and evacuation are 2 different events. In that respect, if I get fire detectors announcing fire or going into fire state in a zone, and the sounders are set to zonal, the sounders from this zone will turn on after the delay you specified previously in the zone. But if you press a call point that is set up to zonal, what's the difference between them is that the call point will bypass the previously set delays for that zone. Delays referring to sounders action. That's why I'm saying they kind of go hand by hand. Again, if I put sounders to common, regardless if the call point is set to zonal, this call point will trigger all the sounders because they're common, they're zonal. And the other way around, if the sounders are set to zonal and the call point are common, then again, it won't work this way. Pressing a call point will not activate only the zonal sounders, it will activate all the sounders. So this is what I mean by they kind of link together. Plus, if they're set to common, the T3, the phase evacuation over here, time before evacuation, this T3 time, it won't be applicable again because there are no zonal settings. Next, it's the settings for the alarm tone and evacuation tone. Remember I said that evacuation and alarm are two different events, so respectively you can set up two different tones for that in order to separate alarm event from evacuation event. By default, the alarm event and evacuation event are set for the same tone, but depending on the country or requirements of the project that you're working on, you can set up choosing one of 32 different sounds for the evacuation and the tone event and the alarm event. Next is class change event, class change tone. A lot of installations, mostly in schools, they use the sounders to announce the beginning and the end of the classes. In order not to confuse the sound with alarm or evacuation sound, you have the option to change that class change tone again from 32 different sounds and use the panel sirens to announce the beginning or the end of the class change. How to log off, that's pretty self-explanatory. If you're in engineer mode, by clicking on and specify the time in minutes, the panel will go back. If you leave the panel in engineer mode, access level, the highest access level, the panel will go back to access level number 1 after this specified time over here. Now, the settings for the sounders in alarm tone can be done individually, every sounder in a loop separately, or it can be done globally from here by setting out the sounders with strobe and sound only, strobe only, or individual. However, the evacuation settings, because evacuation is a global event, you cannot set up individually. You can set up from here globally for all the sounders. How they're going to behave in case of evacuation. Now, next 3 lines referring to the panel connected to voice evacuation system. Usually, a fire panel activates voice evacuation system, and there is voice messages that it's played on the speakers. Now, in order for the people to be able to hear that voice evacuation message, you need the sounders to announce the fire with sound, and then you have to silence them while the voice evacuation message is played. In order to accommodate this, you have the evacuation cycle, voice evacuation cycle on, when the sounders should turn on and for how many seconds, and when they should silence and for how many seconds. That depends strictly on the voice evacuation system that you're using. It might take a couple of seconds before the message starts, it might take more, and then the message, depending on the length of the message, you can silence the sounders. You can silence them completely, or you can leave them just with flash, depending on the silence that you use. And this is last line here for evacuation cycle, inverted. That means that instead of starting the sirens with sound, you can start them silently just with strobe, and after a certain period of time, so you can hear the message, after a certain period of time, you can activate them with sound again. Depends on a voice evacuation system you're using, and how long does it take for the message to start playing, or the needs of the customer that you're doing installations for. So it's pretty straightforward. It's a cycle that repeats again and again and again and again. Last chapter here, or last line, is resound alarm. If it's checked, that means for the panel that in case of a fire, the sounders will start. And if you press silent sounders, this is a global command to stop the sirens. But if another alarm comes, the sounders will start again if this field is checked. That's what means resound alarm. If it's disabled, not checked, after you silence the sounder in the system, another alarm will not trigger the sirens again. What's the use of this? If I can put it into example, let's say you get the silence from you get the alarm event from zone number 1, and you have set up 5-minute investigation time delays of the sounders. On your way, if this one is checked, on your way to zone number 1, after you silence the sounders from the panel, on your way to zone number 1 to investigate the event, if you hear alarm again, that means that another detector has gone into alarm. The chances are that it's real alarm, not a false alarm from one detector. So this way you know how many more alarms occurring while you're going for investigation. Now I'm going to move to inputs, outputs. Now, usually you need to set up the system in such a way that when something happens in the system, to provoke an action from the system to activate, let's say, ventilation system, elevators, escape doors, etc. In order to do this, you use modules. You use so-called Teletech modules and MIO modules, module input outputs. In this example here, I'm using module inputs outputs 22, MIO 22. That has 2 inputs and 2 outputs. Pay attention at this channel 1, 2, 3, and 4, because we're going to use those channels later on. So channel 1 and 2 are input, channel 3 and 4 are outputs. Now here's a shortcut, but limited shortcut. If you want to activate something in a system, you have an option of alarm, evacuate, gas, or panic. In other words, if you connect third-party device to this input and activate this input, it's going to trigger those events in the system. Respectively, the shortcut for the outputs, if you want them to activate upon certain event, you have the options of alarm, evacuate, reset, and sounder mode. If you choose any of this, if this event happens in the system, the output is going to activate itself. Sounder mode means it's going to follow whatever you set up for the sounders. Now, I'm saying that this is a shortcut, but it's limited because you need more than that and a lot of installations. And if you leave the outputs as output, I'm going to give you an example how to integrate it or how to program it into input-output logics. Over here, inputs and outputs. Now you have 250 logical inputs that you can assign to something. You can design an input to monitor the system for something. The most used event and the most comprehensive event that you can choose is action sounder on. What that means, you wanna activate, you wanna send the elevators to the first floor or activate aspiration or air conditioning system when there is fire. But remember, you can set up delays for the sounders delays that are used to investigate the zone and see if it's a false alarm. You don't want to, upon receiving an event, fire or evacuation, you don't want to activate everything right away, because then it makes those delays for the sounders useless. So imagine you get a fire in zone number 1 that has 5 minutes delay for the sounders. The person now, security guard, goes there, investigates, and see that the actual fire, and presses a call point to bypass the delay and activate the system into a fire mode or evacuation mode. This is when you want to activate some relays to send elevators down, open doors, fire escape doors, or other bells or whatever. You don't want to activate them before that. That's why I'm saying when sounders on is probably one of the most used logical input that you can create. An input that monitors the sounders. In case that the sounders go on, then you can trigger different events in the system or different models in the system. So let's say I'm going to go through the process of designing an input. Designing input sounder on. You can choose many other options. You can check this on your own time with the software. You can monitor a zone for fire. You can monitor alarms. You can monitor group. You can monitor time, date, a lot of things. For this example, I'm going to use sounder on. When you're designing an input, sounder on, it's a very good idea to put a name on it, like I'm doing now. If we click apply, the name will appear right in front of right across the input that you're designing. Sounder on. So we design input that monitors when a sounder goes on in the system. When the sounder goes on, you want to activate something. Remember, I have loop with module, input-output module, at address number 5. So I'm going to design an output, which is, I'm again going to put name on it, address 5, channel 3. So now this is just the name. If I click apply, just the name is going to appear over here just to remind me what this output is linked to. The output could be linked to periphery device, loop device, network action event. You have again number of options, and I'm going to use loop device. Loop device was address number 5, loop number 1, channel number 3. Channel number 3, remember, channel 1 and 2 are inputs, channel 3 and 4 are outputs, because of the model that I choose. If you choose model 04, MIO 04, means have 0 inputs and 4 outputs, then every one of those channel 1, 2, 3, 4, they can be used for as an output. But because I choose this model 2 inputs, 2 outputs, that's why the outputs are channel 3 and 4. So this is my output. I'm activating this output model. When do I want to activate, or how do I want to activate it? Activate this model. I want to activate it when input number 1 is on. Input number 1 monitors the sounders. Respectively, with this input, I'm activating this output. And this output is my loop device. Now, with this input number 1, I can activate numerous of things. It's not just one output device that I can activate 250 different devices or 200 different outputs, or I can trigger events with this. For this case here, I'm choosing an output model on the loop because it's the most common use for those input-output relations. Of course, I can trigger evacuation with this input. If I choose here action, I can choose evacuate, I can choose silent buzzer, many options. That's what makes the system very flexible. So going back to my original intention, for the example, was the loop device. So now with input number 1, I'm activating output that I assigned to a loop device. For now, you disregard the name group over here. Disregard the name group. I'll come back to this group and how is it used. So I'm activating output on a loop device with input number 1. What if I want to make more inputs or activate this output from different events or different inputs? Let's say I want to make an input that monitors fire in a zone. Zone in fire, zone number 1. Put a name here again to remind you. Zone 1 fire. Fire. Click apply, zone 1 fire. So now I have second input that monitors zone 1 in fire. Now, remember, one of them follows the sirens, watching for the sirens. The other ones are watching for zone number 1. Zone number 1 is very important for me. So I want to activate this Mio module, the output. I want to activate it when there is sounders on, or if zone number 1 goes on fire. So I can choose here as an activation event my second input that I designed that monitors zone number 1 in fire. So this way you can choose another input and another input and link it to the output model. Now you have options for 4 different inputs to activate the output. This is for now. Later on, I'm going to stretch that and show you how many more things you can put into those fields. Now, it's important to take a note why I'm putting it in this line, not here. And what is this AND means? Explanation coming. These lines here, they correspond to this part of the schematic. This line here, the numbers you enter in this line, they correspond to this part of the schematic. I'll put it again into an example. This first box corresponds to this, second box to this count. Imagine this as electrical impulse that starts from here and it wants to go all the way to the other side where my Mio model is. If this input or this input is not active, respectively this switch or this switch is not closed, because when they're active, it closes the switch, the signal, the impulse has no way to go to the other side and activate my output. As soon as this input becomes active, that closes the contact. So you have a clear path for the impulse to go to the other side and activate respectively the model. Their second box corresponds to second switch. So this way, that's why it says or input. This one, if it happens, or this one, if it happens, or this one, if I put another number here, or another number here. Now, why does it say AND here? This is the relationship between this part and this part of the diagram, of the schematic. If I put any design input, any input that I make over here, let's say I'm going to use one of the ones that I already did, I'll cancel it from here. If I put second one over here, which represents zone number 1 in fire, what's going to happen? As soon as you put number different than 0 here, a switch opens up. This corresponds to the second one, etc. So by putting number 1 input over here on this line that represents this part, as soon as I put a number there, this switch will open up. So now, how is the panel going to react? If the sounders turn on, respectively my input number 1 active, this will close this switch. But the signal will get jumped over here because second part, switch number 2, input number 2 is not active. Unless there is a fire in zone number 1, and then this input is going to close and the signal will go to the other side to my output model. So if I change it to OR with the same setup, if I change it to OR, see how the schematic changes. So now input number 1 represents this part, input number 2 represents this part over here. So now the relationship between both parts now is OR, because if this one happens, the signal will go through. If this one happens, this will close that switch and the signal will go through. If I have nothing here, the signal will go through every time you start up the panel. So choosing these options without having any inputs over here will activate my output. So that's why I'm saying that this in and 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 OR are the relationship between this part on top and this part on bottom. So respectively, AND means these are closed by default. As soon as I represent present number here, this will open up the respective switch. This will open up this one will open up that one. If I put number here, when this input is active, we'll close one of those switches. Respectively, we go to signal type. Not much to explain there. One pulse, continuous. Pulse means pulsating all the time, one pulse, and you set up the duration for that pulse, how long it should be. Now we're going into more details about inputs, outputs. Remember I told you disregard this group. What happened back in time? Back in time, people said, that's perfect. I have four inputs, respectively 4 different events, and I can activate my output mode. What about if I need more than 4? How can you accommodate that need? So what we decide that we can work on both sides, the people that don't need more and the people that need more. So if you don't touch anything on inputs, you'll see that every input belongs to its own group. Input number 4, group number 4, 5, group 5, 6, group 6. So when you go to the outputs and you specify the input number, whether it's the input number or group number, because they're all the same thing. 1 belongs to 1, 2 belongs to 2, 3. It doesn't matter which one you enter here. But if you need more than that, if you need to expand the options in this system, I'll give you an example again. Let's say I need to create 10 different inputs monitoring 10 different zones. So I'll design input number 10, monitor zone 1, input number 11, zone 2, input number 12, zone 3, etc. Sorry. So in order to combine it, because I don't have 10 spots, I have only 4 for the outputs, I can put them in one group. Now, I would choose group 100. It's not likely you're going to go to that many inputs, that many. If you do, of course, you can go to further down. You can go group 250. I choose 100, not to mix up with the other inputs that every input belongs to its own group. So I make input 10. I'll put a name just out of to skip the confusion. Zone 1. Zone 2. Again, I'll change it to group 10. Zone 3. Change it to group 10. And so on. I forgot to mention here that I'm choosing fire in zone number 1, zone number 2, zone number 3, respectively, depending on the input that I'm designing. But what's important here for this example is that all those inputs are in the same group, and you can carry on like this up to 20, whatever you need. So now, all those inputs are in the same group number. I mentioned hundreds, but for some reason I put 10. I don't know why. I'll change it here to 100, just to defer the example better. So I'm going to outputs. I want to activate my output when the sounders are on, or when any one of those zones and this input group 100 is active. So output activation input group number 100. So if any one of these inputs is active in group 100, this is going to activate my output. So that's how you can have more than 4 events over here. And now you have a relation in the group itself. Do you want this input to be active when one of those events or one of those inputs belonging to this input group is active, or when all of them? So there you have the input groups. Choose group 100, and you say the relation in group 100 will be OR, meaning if any one of those inputs in this group 100 is active, the group will be active. Or you can choose relation AND. That means that every one of this input belonging to this group has to be active in order to activate the group. By default, the setting is OR. Hope this example spreads some light between the mystery of inputs and outputs. I can make another example for you. Input number 1 might be a loop device. It might be a loop device. Remember my loop device number 5. A loop number 1 has 2 inputs. So channel 1 and channel 2 are my inputs. If I connect third-party switch, let's say, or activate this input, I want to trigger evacuation. So I name that input number 17, Mio channel 1, address 5. Just to remind myself of what it is. Here comes up right away. Input number 17. I can go and output, choose a free output, that is output type is none, and say my input number 17 is going to activate action in the system, and the action will be evacuate. I can choose different action. I can do class change and use the option, or I can do reset, or I can do silent sounder, silent buzzer. You have numbers of options. So if I set it up like this, put a name here again, evacuate, and upon activation of Mio module channel 1 on a loop, this will trigger action in the system, which will be evacuation. And move to zones. Zones, it's a short chapter. There is a few parameters that I will explain. Zone mode. Zone name is clear, the location of the zone, physical location, or details about where this zone belongs to and how to find it. Normal, double, or 2 devices. It's crucial here to understand what's the difference between 2 devices or double. Double, if it's set up to double, zone number 1 triggers fire from a detector. The panel goes into pre-alarm state, and a counter of 5 minutes starts. Within those 5 minutes, the panel will reset the device that triggered the alarm, and will wait for this device or another device from the same zone to trigger again. But the important thing is that it will reset the device that triggered the initial alarm. If within 5 minutes there's no additional alarm from the same zone, the panel will go back to normal state. If it's within these 5 minutes, if it's another activation, might be from the same detector or any other detector in the same zone, the panel will go into fire. However, that's not the case with 2 devices. Put it simply, if a detector from a zone goes in fire, the panel will not reset this detector. The panel will leave this detector in fire state and will wait for another detector from the same zone for 5 minutes. If there is no another detector going in fire in these 5 minutes, the panel will go back to normal state. Now, why I'm stressing on that? Because let's say in this room that I'm getting this presentation from, if it's a one zone, separate zone, and it has one detector, if the zone is set up for 2 devices, and this detector goes on fire, the panel will start the 5-minute countdown, but it will not reset the detector that triggered the fire. Where respectively, you're never going to get fire from this zone, and it will burn down to ashes. So it's very crucial to know the difference between 2 devices and double. In double, panel resets the detector that gave fire and waiting for the same detector or any other detector from the same zone. In 2 devices, the panel does not reset the device that went into fire state, waiting for another device from that zone. Next, one zone can be set up in 3 different groups. In order not to confuse group with number and different group, that's why we use group A, B, C. You can set up any zone to be one of 48 different groups. That it's kind of a common zone for 3 different groups. What would be the example for that? Imagine you have a hallway with 3 stores, and the hallway you need to be a common zone for the 3 different groups, for the 3 different stores. If you design an input that monitors group for fire, the zone that belongs to the group will trigger fire in this group as well. So it's a common zone between the 3 stores. Zone sounders, you can activate with this group, with this zone, you can activate 3 different sounders group. What would be the example for this? Imagine you have 5 houses. When you have a fire in this house number 3, you have a fire that the sounders go on in group number 3, the house number 3. That's okay, but you need to warn the couple neighbor houses by turning on their sounders as well. So you want to activate sounders group, sounders that belong to group number 2, respectively house number 2, and sounders that belong to group number 4, respectively house number 4. So if I put this zone activates groups of sounders number 2 and groups of sounders number 4, when this house is on fire, it's going to turn on its own sirens, plus it's going to turn on all the sirens that belong to group number 2 and group number 4. So I guess with this we'll end the mystery about this zone settings. One thing that comes to my mind that is applicable for detectors, for zones, for devices, for other thing is called the cloning. Imagine I need all my zones to be with mode double. Now, the long way, I go through every one of them and set up zone mode double, zone mode double, zone, or the delays, or which groups they belong to. Regardless, I'm going to use just double option here to visualize and explain how it works, the cloning. If I hit apply, this will apply this zone mode to zone number 1. Now, if I click apply selected, the panel is going to give me all the available zones that I can choose from. In this example, I'm going to choose all the zones, select all or unselect all. What I want to clone, I want to clone the zone mode. I don't want to clone the name, I don't want to clone the delay, I don't want to clone anything but the zone mode. So I unselect everything and just go on zone mode. I choose only the parameter that I want to clone to the other zones. And if you click OK, then what happens? Look, I go to every zone now, and it's all double, 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 double. The same applies for the smoke detectors, let's say. You want to set up day level and night level, or you want to set them all, if you don't use day and night schedule, if you want to set them all to night level low or high, you can choose. Here's I'm going to add another smoke detector. Keep in mind that this is just the template, but it has all the properties that you're going to have on real devices connected to your panel. So day mode, day alarm level, I want to put it to low, assuming there is a school and a lot of dust because moving people, running kids. And night level, I want to leave it at high. So I want to do this for all the detectors in the loop that are S130. I click apply. In this scenario, I have just one, but whether you have one or you have 200 is the same story. So now I go apply selected. Panel shows me the available detectors that can be set up this way. So I choose them both. And I don't want to clone their names. I don't want to clone their LEDs and etc. All I want to do is clone their day and night alarm level. I click OK, and now if I go to this detector, you can see alarm level low during day, alarm level high during night. So this is it, the so-called cloning option that you can make a template, and with this template you can transfer it or clone it to all detectors, devices, zones that this option is applicable to. I hope it was educational and useful for you, and I guess we'll see you again. Thank you.